Part A, we're asked to calculate the area of this sign, the area of this triangle. First of all, if we mark the side opposite, the angle A as small a, the side opposite the angle B as small b, and the side opposite the angle C is small c. The formula for the area of a triangle is given by A is equal to a half AC sine B. Now, the values that we require in this formula are small a, small c, and the angle B. Small a is 4.2, small c is 3.6, and the angle B is 35 degrees. We now fit them into this formula. So the A is equal to, instead of a half, I'll put 0.5 in the calculator, times 4.2, times 3.6, times sine 35. When we put this in the calculator, we get the answer that the area of this sign, this triangle, is 4.3 square meters. Part B, we're asked to calculate the length of the side AC or small b. Now this is a classic situation for the cosine rule. Two sides plus the included angle. In this case, we're trying to find small b, so b squared is equal to a squared plus c squared minus 2ac cos b. Using the same values as we used before, small a is 4.2, small c is 3.6, and the angle at B is 35 degrees. Fit these values into the formula. B squared is equal to 4.2 squared plus 3.6 squared minus 2 times 4.2 times 3.6 cos 35. When we fit this into the calculator, we get that B squared is equal to 5.828. So that B is equal to the square root of this answer. B is equal to 2.4 meters. B, which is AC, is 2.4 meters. Here we're asked to calculate the size of the angle PRS, or the angle at R. We begin by marking the three sides. Small p, small r, and small s. This is an example where we use the sine rule. The sine rule for this triangle is p over sine p equals r over sine r is equal to s over sine s. Now, we don't know anything about small p or the angle at p. So it's the second part of the sine rule that we're going to use. R over sine r, which is 20 over sine r, is equal to s, which is 16 over sine s, which is sine 44. We can then cross multiply, and we get 20 times sine 44 is the same as 16 sine r. And we can now divide the 16 over on the right hand side to tell us that sine r is 20 sine 44 divided by 16. Doing this calculation on our calculators gives that sine r is equal to 0.8683. And then to find the angle r, which is angle PRS, we do the inverse sine of 0.8683. And this gives us angle r, or angle PRS, is 60.3 degrees. We're asked to draw these lines on the diagram. First line is 2x minus y equals 4. And I've chosen three x values to fit into this equation. First of all, x equals 0. Putting x equals 0 gives us 2 times 0, which is 0, minus y is equal to 4. 0 minus y is minus y. So minus y is equal to 4, which means that y will be negative 4. So we fit negative 4 into the table. Now we fit the value of x equals 2 into this equation. 2 times 2 is 4, minus y is equal to 4. 4 minus 0 equals 4. So the value of y in this case will be 0. So we fit 0 into the table. Finally, x is equal to 4. Fitting 4 into this equation gives us 2 times 4 is 8, minus y is equal to 4. Now 8 minus 4 equals 4, so the value of y this time is 4, and we fit 4 into the table. We'll then be able to go on and plot these 3 points to draw this line. Moving on to the second line, x plus y is equal to 8. Now x plus y equals 8 means that if you add the x and the y coordinates, the answer is 8. So with a value of x equals 2, 2 plus 6 gives you 8. So that will give us the point 26. When x is 4, 4 plus 4 gives you 8. So the y coordinate will also be 4. And finally, x plus y equals 8. When x is 7, the y will be 1. And that gives us 3 points to plot to draw this line. Our first line, 2x minus y equals 4. First point to plot is the point 0, negative 4. Second point, 2, 0. And the third point, 4, 4. We now draw a straight line through these 3 points. And that's the line 2x minus y is equal to 4. The second line, x plus y is equal to 8. Plot the point first of all, 2, 6. 4, 4 is already plotted for the first line, and 7, 1. We now join these 3 points up. And this is the line with equation x plus y is equal to 8. In the question, we're asked to use the graph to solve the system of equations. And all we need to do now is to choose the point where the 2 lines meet. So the solution of the system of equations is the point 4, 4, or we could write x equals 4, y equals 4. This time we're asked to solve algebraically the system of equations. So we don't draw the graphs on this occasion. So our 2 equations are 4x minus 3y equals 5 and 2x plus y equals 5. Now what we try to do is eliminate either the x's or the y's. If we leave the first equation as it is, if we multiply the second equation by 3, this will give us a plus 3y in this position, which will enable us to add the 2 equations and eliminate the y's. So we multiply this second equation all through by 3. 3 times 2x is 6x, 3 times y is plus 3y, 3 times 5 is 15. If we now add these two equations together, that gives us 10x is equal to 20. The minus 3y and the plus 3y cancel. 10x is equal to 20 divided by 10 gives us that x is equal to 2. To find the y value, we fit this x value of 2 into one of the equations. Fit it into the second equation. 2x plus y is equal to 5. So instead of 2x plus y equals 5, 2 times 2 is 4 plus y is equal to 5, which means that y is equal to 1. The solution to the system of equations is x equals 2, y equals 1. A survey in the number of pupils in each subject class in third year is shown below. We are asked to find the maximum, the minimum, the median and the quartiles for the data, and we're then asked to draw a box plot. First of all, we put the data in order from the lowest to the highest. So we can see that the minimum value is 22, maximum value is 40. To find the median, because there's 10 numbers from the list, there won't be a particular value on its own in the middle, so we have to find the average of the two middle values. So the median is found halfway between 32 and 34, so the median Q2 is 33. To find the lower quartile, there's 5 numbers below the median, so there will be a particular value on its own in the middle, and that value will be 25. So Q1 is 25. There's 5 numbers above the median, so the one in the middle will give the upper quartile. So 36 is the upper quartile Q3. We've now to draw a box plot. First of all, we need a scale going from 22 up to 40. Now we draw a vertical line at each of the values for the minimum, Q1, Q2, Q3, and for the maximum value 40. So there's the minimum value. Q1 is 25, Q2 is 33, Q3 is 36, the maximum value is 40. We now draw the box plot. A group of 60 tennis professionals were asked which court surface they preferred. The table below shows the results. 20 out of the 60 said clay, 15 out of the 60 said hard court, and 25 out of the 60 said grass. First thing we're asked to do is copy and complete the table to work out the angles in the pie chart. "20 said clay, so we need to work out 20 divided by 60, and then if we multiply this by 360 degrees, the number of degrees in a full circle, we get that the angle to represent clay is 120 degrees. To work out the angle for hard court, it's 15 divided by 60, and then times by 360, 90 degrees for hard court. Finally, grass is 25 divided by 60 times by 360, which is 150 degrees. We've now to draw a pie chart to show the data. Place our protractor over the circle. And first of all, we want to measure an angle of 120 degrees. And that will be on the inside scale. And then we mark this with clay. The second angle is for hard court, which is 90 degrees. So we place our protractor on the circle and turn it round. And then marking an angle of 90 degrees and draw a line from the centre. And this is marked then hard court. The remaining angle of 150 could be checked, but since we know that all three add up to 360, the remainder must be for grass, 150 degrees. The temperature in 10 places in Scotland on April Fool's Day are shown below. So we've got 10 temperatures in our data list. We're asked to find the mean and the standard deviation of this sample, and we have to show all the working. First of all, we add all the numbers up, so sigma x, and that gives 137. To work out the mean, we need to divide this by n, which is 10. So the mean is sigma x divided by n, which is 137 over 10, which is 13.7. So the mean x bar is equal to 13.7. Now to find the standard deviation. We draw up a table with 3 columns. In the first column, we put our x values. The second column, we work out x minus x bar for each of these x values. In the third column, we'll square each of these answers. So firstly, 13 minus 13.7 is minus 0.7. 11 minus 13.7 minus 2.7. 16 minus 13.7 is 2.3. 15 minus 13.7, 1.3. 12 minus 13.7, negative 1.7. 13 minus 13.7, negative 0.7. 14 minus 13.7, 0.3. 12 minus 13.7, negative 1.7. 16 minus 13.7 is 2.3. And 15 minus 13.7 is 1.3. We now square each of these values. Minus 0.7 squared, 0.49. Minus 2.7 squared, 7.29. 2.3 squared, 5.29. 1.3 squared, 1.69. Minus 1.7 squared, 2.89. Minus 0.7 squared, 0.49. 0.3 squared, 0.09. Minus 1.7 squared, 2.89. 2.3 squared is 5.29, and 1.3 squared is 1.69. Notice that all of these values are positive. We now need to add all these up. So adding the last column gives 28.1. Formula for the standard deviation is S is equal to the square root of the sum of the x minus x bar squared, the last column we've just worked out, divided by n minus 1. The sum of the x minus x bar squared was 28.1. N is 10, so we take 1 away from this to get n minus 1 is equal to 9. So fitting in the values, S is equal to the square root of the sum of the x minus x bar squared is 28.1 over n minus 1, which is 9. So S is the square root of 28.1 divided by 9. And this works out to be 1.77. So the mean is 13.7 and the standard deviation is 1.77.
The joiner finds that the daily profits of his business depends on the number of hits his website receives daily. We've got a table here of the number of hits, H, against the daily profit, P. First thing we're asked to do is plot the points and draw the best fitting straight line through them. First point is 10, 200. So we plot 10, 200. Then 20, 204. 30, 210. 40, 216. And 50, 220. We then draw a straight line through the points as best we can. We're then asked to find the equation of this line. First thing we do is we need to find the gradient of the line. So we draw a line across and a line up between 2 points on the line. And then measuring the squares, we see that it's 15 up between these 2 points, and it's 30 across. This means that the gradient, m, is equal to 15 over 30. 15 divided by 30 is 0.5. So the gradient of our line is 0.5. In order to find the equation, we must first of all find where the line crosses the vertical axis, the daily profit axis. We see that this is at the point 0, 195. We can then work out the equation of the line. On the p-axis is the daily profit, and the cross-axis is the number of hits. We could call this H. So p is equal to the gradient, 0.5 times H, plus 195, the place the line crosses the p-axis. So this is the equation of our line. P equals 0.5H plus 195. Part D, we're asked, using your equation, estimate the daily profit when 80 hits are made. So we need to fit H is equal to 80 into this equation and work out the value of P. So P is equal to 0.5 times 80 plus 195. 0.5 times 80 is 40. So that's 40 plus 195. 40 plus 195 is 235. So P is equal to 235. So when 80 hits are made, the daily profit is £235. A bag contains 25 balls, numbered 1 to 25. We're asked to find the probability that a ball chosen at random is greater than 20. Now, there's 5 balls that are bigger than 20. So the probability is going to be 5 over 25, which is 1/5.